Hello everyone, welcome back to our channel Problematical. We'll discuss solved examples from Chapter 1 Sets, Class 11th Maths NCERT today. So first question is, write the solution set for this equation in roster form. Now the equation given to you is x squared plus x minus 2 is equals to 0. It's a quadratic equation, so definitely by solution we will mean that x can have two values, x squared plus 2x minus x minus 2 is equals to 0, x in common if you're factorizing it, minus 1 common, x plus 2, and you're left with x plus 2 and x minus 1. The values of x would be minus 2 and 1 respectively. Solution set of this in roster form, we know that x can have two values. These are the solutions. Putting it in a set, a is equals to minus 2 and 1. This would be the solution set of the given equation in roster form. In roster form, we mention the all the elements present in the form of a set. Write set x such that x is a positive integer and x squared is less than 40. Let a is equals to a set of all x such that x is a positive integer and x squared is less than 40. This you have to write in roster form. So positive integers means integers which are 1 or greater than 1, 1, 2, 3, 4 and so on. X squared is less than 40. Now squaring, we get 7 square is equals to 49 and 6 square is equals to 36. So your x square should be less than 40, which means 6 square is 36 is less than 40. X can have any value between 1 to 6 in this to satisfy this condition. So x can be either 1, 2, 3, 4, 5 or 6. These values of x satisfy both the condition that it is a positive integer and its x square is less than 40. So a value is a set of all x. So it will hold values like 1, 2, 3, 4, 5 and 6. Next. Write the set A, which is given in set builder in roster form. You have to write it in set builder form. So to write anything in set builder form, you have to form a relation. You have to find a relation amongst different elements. What is common that you can see in the different elements of the set? You can write this A set as 1, 4 can be written as 2 square, 9 as 3 square, 4 square, 5 square, and so on. You can understand, you can write 1 as 1 square as well. So the base values are natural numbers and the power is 2, which is static. So A can be written as a set of all x such that x is equals to any value is base to the power 2. Base to the power 2. Base is varying, that's why we've taken a variable. Then n belongs to a natural number. It is observable that n can never have value less than 1 and it is always progressing in counting numbers. So n belongs to natural numbers. This would be set builder form. Next. Write the set of this particular, the set is given to you in roster form and you have to write it in set builder form. So again, let A is equals to given set 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7. Now, every ratio, if you observed, the numerator and denominator can form a common relation amongst different elements. If you consider the numerator as, if you consider numerator as x, then the denominator seems to be like x plus 1. For every value, place x is equals to 2, you get 2 plus 1, 3 in the denominator. 3, you get 4 in the denominator, and so on. So you can say that A is a set of all y such that y can be expressed as a ratio of x upon x plus 1, where your x is equal to, x belongs to a natural number, because x is a numerator. In the numerator, you have 1, 2, 3, 4, 5, and 6. All 6 values are natural numbers, and your x is less than equals to 6. It cannot have any value which is greater than 6. Next, match each of the sets on the left described in a roster form with same sets on the right described by set builder form. PRINCEL. If you can consider the right hand side, you can represent the right hand side. You can see that the right hand side is mentioned in the form of set builder form. One approach you can take is by converting all these 4 A, B, C, D into roster form and then matching it with the left hand side. Or you can plainly see by observation, these words would be X is a letter in the word principal. So this can be matched with D. By observation, you have 3 and minus 3. Let's convert ABC into roster forms. So A is a set of all X such that X is a positive integer and is divisor of 18. So let's calculate the divisors of 18. 18 has divisors 1, 2, 3, 1 into 18, 2 into 9, 3 into 6. Is it divisible by any other value? No. So, sorry, 6 3s are 18, 9. Yeah, it's not divisible by any other value. So these are the divisors of 18, or 8 is the multiple of these values. So for A, you can form a set of these values 1, 2, 3, 6, 9, and 18. From the figure, you have this is A. B. X is an integer and x square minus 9 is equals to 0. It's given that x square minus 9 is equals to 0. So x square will be equal to 9, which means x can hold either two values, plus 3 or minus 3, which is this set. By default, your second will be C, but let's see it. X is an integer and x plus 1 is 1, which means x is equals to 0. So this value is equals to this. Next. State which of the following sets are finite and infinite. First, X such that set A is a set of all X such that X belongs to natural number and this quadratic equation. So from here you can see that I'm calling these sets as A, B, C, D, and E. So set A in roster form will be either 1 or minus 1 because it's a set 1 or minus 2. Plus 2, sorry. How did we come up with 1 and 2? It's given that x minus 1 into x minus 2 is equals to 0, which means that x is either equals to 1 or x is equals to 2. Next. So this is a finite set because it has finite number of elements. Second, B. N and x square is equals to 4. So it's given that x square is equals to 4, which means x will have two values, plus minus 2. Plus 2 and minus 2. C. 2x minus 1 is equals to 0, which means x, 2x is equals to 1, which means x is equals to 1 by 2. But it's given that x is a natural number, and this is 1 by 2 is not a natural number. So this is a null set. Again, it is B is a finite set, finite elements, and C is a finite set. Next. X is equals to, x belongs to natural number and x is prime. Now, when you say x is prime, there are infinite prime numbers. 2, 3, 5, 7, 11, 13, 17, and so on. So this is an infinite set. Next, x belongs to n and x is odd. Again, for E as well, you can have odd value, which means 1, 3, 5, 7, and so on. This is also an infinite set because there can be infinite values in this set. Next, find the pairs of equal sets, if any, give reasons for this. Now let's convert, let's write all these sets in roster form. So A is 0, B is a set of all x such that x is greater than 15 or x is less than 5. So 5 and 15. Now, it's given that x is greater than 15. So x can have any value on the right hand side of 15. Also, it's given that x is less than 5. So x can have any value on the left hand side of 5. Now, if this is written in the set builder form, then and separated by and, then both conditions are to be satisfied. That means your x value can either be has to be in both the intervals, from -infinity to 5 and from 15 to infinity. However, by observation, we can say that this is not possible. So there is no element which comes in both the regions or which satisfies both the equations. Hence, B is a null set. C. All x such that x minus 5 is equals to 0. When you take x 5 on the right hand side, you get only one element 5 in the set of C. D is a set of all x such that x squared is equals to 25, which means for your D, x can have either plus 5 value or minus 5 value. E is a set of all x such that x is an integral positive root. So it's an integer. It is a positive root of this equation. So the equation is x squared minus 2x minus 15 is equals to 0. A shortcut to calculate this is first factorize 15. 15 can be factorized as 3, 5. We need a difference of 2 and both the signs are negative, so greater number has a negative sign. Now these are the values that you split the middle term as. If you need to calculate, split the middle term as, in which case you'll get x plus 3 and x minus 5 based on the two values that you will split your middle term as. You can directly write this after these with their respective values, and later on x is equals to minus 3 and x is equals to 5. So this is a set where you have minus 3 and 5. So if you observe A to E, you cannot find any two sets which have same elements or which have common elements. So hold on. Integral positive, right? There's a positive root that has to be mentioned. You cannot place minus 3 over here. You have to have only the positive root. So there is 5 over here. By this, you can see that C and E, these both sets are the same. So E is equals to C. Rest all are not equal to one another. You can even mention those. A is not equals to B is not equals to D. C is not equals to or is not equals to C. And at the same time, A is not equals to B is not equals to C is not equals to not C. D is not equals to E. Next, Which of the following pairs of sets are equal? Justify your answer. Now, in the first section, the X is a set of alloy. So write these elements in roster form. We won't repeat L, even though L is mentioned twice. B is L, O, Y, and E. Now, your A is present over here, L is present, O is present, and Y is present, and both the sets have same number of elements. So these are equal sets. They're equal sets because all the elements are of set A, X are present in set B, or X is a subset of B, since all set of elements of X are present in B, and at the same time B is also a subset of X, since all the elements of B are also present in X. This means that X is equals to B. Second, the A is a set of all X such that n belongs to Z and n square is less than equals to 4. So n square, which square is less than equals to 4? If you consider positive value, 2 square is equals to 4. Beyond this, 3 square will not be less than equals to 4. So positive values can be 1 and 2. Since it's a square, -1 and -2 will also hold the same value. At the same time, for -3, the equation will not hold true. And you have 0 as an integer as well. So A is -2, -1, 0, 1, and 2. B is a set of all X such as X is a real number. And X squared minus 3X plus 2 is equal to 0. Now from here, you can have the factors X minus 2 and X minus 1. With this, you can have the values of X as 1 and 2. Obviously, A is not equals to B, so these are unequal sets. Next. Consider sets phi, A, B, and C. Insert the simple subset and not a subset between each of the following pairs of set. So, phi and B. Phi is in B. If you consider your set B, B has the elements of 1, 5, and 9. Subset, you place a value subset only when the elements on the left-hand side are present in the right-hand side. Phi, as we know, is a null set. So phi does not has any element. If there is no element, there's no element to compare this phi with B. Also, there's a general definition that phi is a subset of all the sets. So here the answer is subset. Second, A dash B. Now A has elements 1 and 3. 1 is present in A, 1 is present in B, 3 is present in A, but 3 is not present in B, which means all elements of A are not present in B. So A is not a subset of B. Third, A dash C. A has elements 1 and 3. Both the elements of 1 and 3 are present in C as well. So A is a subset of C. B and C. B has elements 1, 5, and 9. Have 1, 5, and 9. All sets of B are present in C. Hence B is a subset of C. Next. A and B sets are given. Is A a subset of B? So A has elements A present over here, E, no, I, not present, O, not present, U, not present. Since E is a subset of, E belongs to A and E does not belong to B. If even a single element of set A does not belong in B, then A cannot be a subset of B. Therefore, A is not a subset of B. Why? Because elements of A are not present in B. Is B a subset of A? B has elements like B, C, and D which are not present in A. So, C is present in, B belongs to capital B and small b does not belong to capital A. Therefore, B is not a subset of A. Next, A, B, and C are three sets. A belongs to B. That means A is an element of B, and B is a subset of C. All the elements of B are present in C. Is it true that A is a subset of C? So let's see. If not, give an example. So to understand this kind of question, we'll solve it with the help of an example. Let A be a set of two elements 1 and 2. It's given that A belongs to B. That means in a set of B, A is an element. You can have other elements in B as well, say 3, 4, and 5. You can also write this B as 1, 2, 3, 4, 5. If you can observe over here, never get confused in this. Till the first comma arrives, this complete thing is one element. Second element, third element, and fourth element. So it's also given that B is a subset of C. This is given, and it is given that B is a subset of C. This means that all the elements of B are present in C. So C can be any set like A, 3, 4, 5, 6. All the elements of B are present in C. Now by observation, can you say that A is a subset of C? For A to be a subset of C, all the elements of A should be present in C. The elements of A are 1 and 2. As you can see, 1 and 2 are not these elements of C. A is an element of C, but 1 is not an element of C. Even if you write this in this form, still you cannot say that A is an element of C, or 1 is an element of C, or 2 is an element of C. A is an element of C. So 1 belongs to A, but 1 does not belong to C. Hence, A is not a subset of C. Let A, B, C be three sets. A belongs to B, and B is a subset of, hold on. Right. I failed to mention question 12, I guess. So we have question 13, but not question example 12. So this is not 12. Example 12 states, let A is equals to 2, 4, 6, and 8. B is equals to 6, 8, 10, and 12. You have to find A union B. Now, to find A union B, the best thing to do is write all the elements of first set. Now, consider the second elements. 6 present, 8 already mentioned. So, write those elements in B which are uncommon with A. This is A union B. A and B are given. You have to show that A union B is A. Now, A union, let's calculate A union B first. A union B would be A, E, I, O, U, all the elements of first set. Second set, you have A present, I present, U present. So there isn't any element in B which is different from the element of A, and this itself is in set A. Here, your B is a subset of A. All elements of B are present in A. When this happens, then A union B will be equals to the bigger set, which is A, and A intersection B will be the smaller set, which is B. X is a set of three elements. B, the set of students in class 11 who are in this school hockey team. Y, again 3 elements. Be a student of a set of students of this. Find X union Y. So again, X union Y would we mention all the elements of set X. Ram, Geeta, Akbar. Then mention all the elements of Y which are different, which are not mentioned yet. Geeta is present, David not present, Ashok not present. Next. It's also mentioned find X union Y and interpret the set. What do you mean by interpretation? Interpretation means to try and understand what you calculated. X union Y would be set of students of class 11th who are either in the school hockey team or the school football team. Next. Consider sets A and B in example 12. Find A intersection B. Now in example 12, we had 2, 4, 6 set and 6, 8, 10, 11. As you can see, the common elements over here are 6 and 8. So in the same question, we can write A intersection B will be equals to 6 and 8. Those elements which are common in both the sets A and B. Consider X and Y in example 14. Find out X intersection Y. Now we know over here, intersection Y are the common elements. Geeta is the only common element over here. So again, your X intersection Y will be equals to Geeta. A and B side sets are given to you. You have to find A intersection B and hence show this result. So A intersection B, common elements, the smallest set is B. So let's compare it with, start with B. 2 is present, 3 is present, 5 is present, and 7 is present. Here also B is a subset of A. So intersection will be the smallest set B. So A intersection B, B will be equals to 2, 3, 5, and 7. Common elements amongst the two sets. Also, the set is equals to B, hence proved. A and B sets are given. You have to find A minus B and B minus A. Now, A minus B is written as A intersection B dash or A minus A intersection B. So, all you have to do is take the set A, 1, 2, 3, 4, 5, and 6, and subtract it from intersection of the two sets. 2 is common, 4 is common, and 6 is common. 2, 4, and 6. So remove these elements from the first set. You're left with 1, 3, 5. This is A minus B. What is B minus A? From the set of B, you have to remove those elements which are common between A and B. So in such a scenario, you know that all the elements of B are common between A and B, which means that your not all the elements of B, 3 elements, 2, 4, and 6 of B are common between A and B. So you're left with only a single element A from B, which are not common between A and B. From the observation, we can see that A minus B is not equals to B minus A. V and B are given in the next question. We have to calculate V minus B and B minus V. V minus B, take the set V, A, E, I, O, U, and then subtract the common elements from it. A is common, I is common, and U is common. So you're left with E and O. B minus V would be, again, writing A, I, K, and U, and subtracting the common elements, which is common elements, which is A, I, and U. You'll be left with a singleton set A. Now U is given to you and you have to find out A dash. when you say A dash, we know that U is a addition of elements in A and elements in A dash, or A dash can be written as U minus A. That means from the elements of U, you have to subtract all the elements of A. A has 1, 3, 5, 7, 9. If you subtract them, remove this 1, 3, 5, 7, 9. Here A dash you'll be left with 2, 4, 6, 8, 10. This is A dash complement of A. We'll continue the rest of examples of this chapter in the next class. Thank you.